this. Here's what we call a piecewise function. It's got two different rules. X squared when x is less than 2, or this, which is a parabola, and 1/2 x minus 5 when x is greater than or equal to 2. And we're supposed to find the limits of that function as x approaches 2 from the left of 2, as x approaches 2 from the right of 2, the limit as x just approaches 2, and also these two limits down here. So I'm going to go straight to Desmos, and we can talk about what's happening. So here's f of x, the parabola x squared. It's the full parabola. But if I add a domain restriction and say I only want to see the graph when x is less than 2, there it is. Likewise, h of x, if I remove this domain restriction, looks like this. It's a line that goes on forever in both directions, but I can add the domain restriction x is greater than or equal to 2, and we only have that part. Now, here is how you write g as a piecewise function, combining those two functions. In Desmos, we still use the braces to bound the function. And then the rule comes first. X is less than 2, colon, there's the rule, x squared. Comma, now we're going to have another piece. Another piece is x is greater than or equal to 2, colon, there's the rule, 1/2 x minus 5. So that's a graph of g right there. And if I want to show the endpoints, 2, -4, label, that's actually the function value, because when x is 2, we're using the second rule, greater than or equal to 2. When x is 2, we get a value of -4. This point, 2, 4, has an open circle on it because it's not really on the graph of the function, but it is the endpoint. Now let's use this little table here to talk about the limits. As x approaches 2 from the left, that's numbers like this, 1.99, 1.999. We're getting closer and closer to this value 4, because see, we're coming in from the left of 2. So the y values are getting closer and closer to 4. But if we come in from the right of 2, that is this way, we're getting closer and closer to -4. So when you have to answer the question, what's the limit of g of x as x approaches 2, does not exist, because the limit from the left does not equal the limit from the right. That's the whole point of this exercise, is to show that the limit as x approaches 2 does not exist, because the limit from the left does not equal the limit from the right. On the other hand, as x approaches -2, from the left of -2 or from the right of -2, that's this point right here. And from both directions, the limit is the same. It looks like it's 4. Similarly for the 6, from the right of 6, we're approaching that number right there, which looks like -2. And from the left of 6, we're approaching -2. Go like that to bring these all into play. So there you go. Hope that helped. And when you're sketching this, you kind of sketch the parabola, but maybe erase the portion of the parabola that's to the right of 2. Similarly, for the line, we erase the part of the line that's to the left of 2, putting a solid circle there, open circle there. There you go. Hope that helped. If you have any questions, post a comment.